Welcome and thank you for tuning in. Please subscribe to the channel so that you can get all the videos that I upload. Please like the video and share. So today what I want to look at is a couple of topics in C++ and programming. So there is number one, which is sequential structures in writing programs and algorithms. And then we have arithmetic operators. Then we will look at how to format numeric output. I will also just throw in the function library in there, but the main part would be just to look at how to format your numeric output. So let us begin. I have written a couple of notes here just to structure and guide the lesson. So the first topic would be to learn how to write algorithms using sequential structures. Now, before I define what an algorithm and a program is, I would like to just go through these structures quickly. So the first thing that you will need to understand before you would be able to write these sequential structures or to understand the sequential structures is to first understand input data and output data in programming. So now input data in most cases is just defined as the data set or sets or the data that is going into a system or a process or a program, in our case in programming. And then the output data is what now comes out of that system. Now it's really as simple as what I have tried to demonstrate here, that in most cases we look at the data that is going into the system as raw data. So this is the data that has not been manipulated yet by our process. This is the data that is going into a system. And in the process, you can have logic to manipulate the data, in our case in programming. So once the data has been manipulated, what goes out of the system, that's what is defined as output data, which will be the process data, the required or the desired data. So that is just a simple flow of input and output data, as well as the definition of what an input and output data is. So now the first sequential structure that we will look at is what is called an IPO chart, which stands for input, process, output. So it's also based on input and output data. Now what this IPO is, it is a table that has 3 columns. So these columns define your input, your process, and your output. Now I just want to quickly give you an example of an IPO diagram with a simple problem. Let's say we had a problem statement that requires us to calculate the age of a person and then divide by 2. Now obviously this program statement requires us to know the year at which this person was born, right? Calculate the year to date, meaning the age of the person in 2023. And then divide this age by 2 for whatever reason. So we need to divide. Okay, let me not use this because this is known as modular now in programming. So let me just say divide by 2 and then show the output, right? So this is our problem statement. Now if we were to write an IPO diagram for this problem statement, we would then have our 3 columns, of course, which is your input, and then we'll have our process, then we'll have our output. Now let me check if my shape setting is on so that it can fix the shapes that I'll be writing here. There you go. Now this is a bit small. I'm going to just control like that. Now let me try to draw a longer one. So this is our table and our columns. So obviously the input and output column will obviously be a little bit thinner because there's not much that you are going to write there. So I will make this one as thin as possible. Then your input data, you know, that's just the year. A year. So you can also write that the year can be a whole number or an integer, but I'll just say the year must be a whole number. Of course, the year can never be a decimal, but just to, okay, I think my column is a bit too small. Let me increase that. Whole number. And then the process would be to get the difference between year, which is our input, and 2023. This will give you the age of the person. Now the process is obviously what defines a step-by-step outline of how your process will manipulate your data or your input, which is the year. So we take the year, we get the difference between 2023 and your year, that will give us the age of the person, and then we divide age by 2. Then your process then is done. Then I'm just going to say here, display answer. Because at this point, that's all we need to do now, is to show what is your age divided by 2. So this is a simple example of what an IPO chart looks like. It is a 3-column table that defines your input, which is the data that will go into the system. Your process defines what your system is doing, and then your output describe what comes out of your system. So that is an example of what an IPO chart looks like. Then now there's another structural sequence or a sequential structure that you can use to define your algorithms or programs, but it's mainly defining algorithms. Now it is called a flowchart. A flowchart is a block diagram that shows a system or computer algorithm. So if we were to define a flowchart or write a flowchart for the same problem. Now, a flowchart is a bit more defined and has a couple of rules compared to the IOP chart. So I know that on the start it's an open circle, or you can simply write start and put it into a circle. That's the first part. So this is an oval, but it should be a circle. Then the next step would be to take in your input, which is the year. Now an input is taken using the rhombus, shape. Then this will be the year. So from your start, try to align this circle. Okay. The year is not moving. Try to use this method. Okay, looks like they're aligned now. So you will need an arrow in between to show the process flow. Then from here, we have taken in our input. Now we want to define our process. Now the process can be a rectangle. So it will take the 2023, which is the current year, subtract the year of birth. That's the first part. You can separate the two processes, by the way. So this is the first part, and then the output there would then be taken to a second output to say whatever answer you get there, you divide it. So the answer, or so you would say the output from that box, you would divide it by 2, and then you'd have a second box here, which this is fine, but I don't think it's necessary. You can just write this. It will be more neater if you write it all under the same box. So let me just go back. So I will just define both of those processes. So the first part obviously is to subtract those and then divide by 2. That will then give you your entire process, this box. Then the output now, that will be the answer. It is to display, because this is also display answer, because this is also an operation, just like calculating the answer here, which is subtracting from the current year, then divide by 2 the answer. This is also, will get a rectangle. Then this is to show that you are stopping the program or stopping one process. Now, if you were to use a shape for this one, it is a shaded circle. This one is an open circle. Then there, this is how your flowchart will look like. And then if you look at those, you can clearly see that even on the flowchart, the input is clearly defined here. This is our input. And then this part here defines our process. And then this part, it is your output. Now on some flowchart, it may not be this couple of blocks and this symbol, but in every flowchart, you can clearly single out the input which goes into your process. Your process might contain a couple of steps, which might have a couple of blocks in your flowchart, but those couple of blocks, they make your process, which is your system, and then in the end, you should have the desired output or whatever your process is required to achieve at the end. So that is the output part. Now moving on to the next and last sequential structure. Now the sequential structure that we'll look at for the last time is the pseudocode. Now a pseudocode, it is an informal way of writing an algorithm without using any strict programming language syntax. So it's a plain text, it's an English-like text. Now let us continue with our trend of using this problem statement. So if I were to write a pseudocode for this problem statement, it would be something like this. Sorry. Now, this depends on the person most of the time, but I will try to write it as plain text as I possibly can. Now, I would want to go start, but in a program running, the program is starting, then I will want to start by saying first point. So now with pseudocode, I think it's very advantageous and very simple to write it in point form, because it can be written in a paragraph, but just write it in point form. So the first part would be to maybe ask the user to enter the year. So I will want to first maybe say I want to display a string or text that says enter year of birth. So I'm not interested in the month and day, I just need the year. Then the second part now would be to enter the year, which is writing the year of birth, or entering the input data, which is the year, to the system. Then the next point would be to take the year and subtract it from 2023. Then subtract the year from 2023. Now this is a bit defined and clear, because I'm defining my steps in this pseudocode. That's what a pseudocode does, right? Exactly like your IPO chart is done, and then also your flow diagram is done. Now this is obviously calculating age, and then divide the age by 2. Then, which this now will give you the final answer or the output data, and then just display the answer. Now we can also break this down and look at it from an input, process, and output perspective. So here, this phase 2, that is the input. These 2 points, they define your process. And then this last one is your output. So even the pseudocode can be looked at the same way, but all 3 structures, they define your algorithm. It's a step-by-step definition of what your algorithm will look like from start to finish, which is from input to output. Now I hope that is clear. So we've defined the three: IPO chart, you have a flow chart or flow diagram, and then you have a pseudocode. Now, the next part that you would want to understand is how to test your process if it is doing the right or the expected manipulation of data. Now, test data are data sets of input and output that are tested and validated to be true. Let's say now I was calculating or I was creating data sets for this algorithm that I have created here. Now we know that given the year 2000, if you subtract that from 2023, you will have the age as 23. And then if you divide 23 by 2, you should have 11.5. So this is what a data set, or sorry, a test data looks like. It is a tested and validated set of inputs that will go into this black box, which is the process that we want to write or develop. Then that should be the output, which this is what we expect. The answer 11.5 for 2000, and then go a year down, which is 99. Then we know that 99 must give us an age of 24 this year. And then you divide that by 2, you get 12. So this is what a test data looks like. It's what we have tested and validated to be true. Know that if you were born in 99, if you subtract from 2023, you'll be 24 years old this year, regardless of whichever month you are born in. We are just focusing on the year. And then if you divide 24 by 2, that is 12. So this is what you use to test if your process is working correctly. That's what a test data is. So it's using data which has a known or expected output. Then last but not least is what we have been trying to define with these sequential structures. It is an algorithm. Now, what is an algorithm? I have defined it here. This is what an algorithm is. It is a step-by-step procedure that defines a set of instructions. So what are instructions? Instructions, they outline a process that must be followed in order to get the required output. So that's what an algorithm is. This is a typo here. This is supposed to be instructions or instruction, right? They outline a process that must be followed in order to get the required output. Then what is a program? A program is then a set of instructions that a computer can execute or run. So now you understand what we have been doing here. We have been defining an algorithm, right, that will take in a year and give us the age that is divided by 2, or half of the person's age. So moving on to the next part. Which is learning about arithmetic operators. But before we do that, I want to then show you how to take a pseudocode a flowchart or a IPO chart and convert it or write it into a program, an executable program. Now for that, I'll be using VS Code. Let's create a new file and say, this is an example that I've given .cpp. Now, for those who understand C++, I have a video that shows how to install the C++ compiler and how to write your first program. Please go and look at that. It will show you how to start or write your first program, which is understanding that you need your hashtag include for input, output, and end line, which we are going to use in this program. And then you'll understand what namespace std is. And then you'll also know that you need the main to run a C++ program. Now you need a return at the end to show that the code is run successfully. Then for simplicity, I'm not going to take the input for now. I'm just going to say int define the year, and we have our data sets that we will use to prove that our code is correct, which is the year 2000 and the year 99. So I will start by the year 2000. So we are expecting 11.5 as the answer here. Now the first part, if you look at our sequential diagrams, which I'll just look at the flowchart, right? We have the year now. We have taken in the input. So we need our process. Our process says subtract the year from 2023, which will give you age. Now I'm just going to say age is going to be 2023 minus the year. So I need to use the assignment here. And then I'm going to say now the answer might be a decimal, so I need to use a double for that. And then age divided by 2. Now this will give us our age. Now I'm then going to display, because that is the last part of our algorithm. Display answer is equals to and line. If I run this program now, at the end I should see answer is equals to 11.5. I did not output the answer, so I need to output the answer here. And the code again. So it says 11. So what it did here, which I will explain as we go along, what casting is. So what the compiler does here is that it sees integer here, and then this 2 is not helping as well because it's an integer. Now an integer divided by an integer should give you an integer. So it will take that 11.5 and only take the integer in that 11.5, which is 11. Now, if you want to tell the compiler that it should treat these numbers as both double or give you the answer or the output here as double, you can explicitly tell the compiler to say, give me the double in this answer, which should be 11.5 now. So it is not 11.5 because the result here is already int. So what you can do is to then say, treat this number as a double and treat this number as a double. So this now is an explicit cast as well. It should then give you a double divided by a double, which the answer should be a double. Then when you run that, I've highlighted, so it's running the highlighted part. Sorry. Clear this. So when you run this now, it should give you 11.5. So now we understand that from the first data set, or the first data, input and output, our program seems to be working. Now let us use the last test data. If this is true, then it means that our algorithm or program is working. Now let's write that. So you can see that the answer is 12. So this is how you convert your return algorithm into a program. So this is a defined algorithm using the IPO chart, the flow chart, or the pseudocode, and then this is your program. Now let us move on to arithmetic operators. I hope that made sense on sequential structures that are used to define an algorithm, and then how to take that algorithm and write a program, and how to test your program using test data. Now moving on, the second part will be our arithmetic operators. So now it is important to first understand what an operator is, which I have defined for you there. It says that an operator is a character that represents a specific mathematical logic. Now I've given an example quickly to make sure that you understand that definition. So we have this new operator in programming coming from high school. It's called the modulo operator, which just gives you the remainder when dividing. So now a quick example would be, so if I were to quickly give you an example of the mod, let's say we have 1 divided by 2. This will give you 0.5. However, if you look at how this is calculated, it goes, how many times does 2 go into 1? That is 0, comma, the remainder will be 1. Then you add a 0. So now the new number is 10. So you go, how many times does 2 go into 10? It is 5. Then understanding this process here will help you understand the mod. How does the modding work? So now when we go to the mod will say 1 mod 2. Now the remainder of this, as we have explained here, is that when you say how many times does 2 go into 1, it goes 0 times. The remainder is 1. So now 1 mod 2 will be 1. It's not going to be 0.5. Right? Let us look at this using the compiler. I will then create a new file here called operators.cpp. I will copy over on some of the files that I have here so that I don't have to write all the IO streams and namespace here. Let me remove these 2 files. Let me remove that logic. Then I will go cout 1 divided by 2 and line. Now, as you have seen on the previous example that I've given, that this is an integer, this is an integer. So this will just output an integer, which is 0. Now you have to let the compiler know that these are decimals. So the first part that I showed you was to typecast each number to tell the compiler that no, this is a double, this is a double. So that will then give you 0.5. If you run that, you'll get 0.5. But also, you can just write this as a decimal number by appending 0.0, 0.0. Now, this is a decimal number, so that must give you 0.5. So as you can see that 1 divided by 2 is 0.5. If you mod 1 by 2, now mod only works with integers, so you'll need to revert back to integers. Now if you say 1 mod 2 and you run your code, you will see that it's not 0.5 now, it's 1, because mod returns the remainder. As I've explained, that 2 goes 0 times into 1 and the remainder is 1. There is the remainder. Now I hope you understand the examples that I've given as your operators there. And then we have what we call as operator precedence. Now operator precedence is mathematical rules that govern how to use these operators, right? It defines the order of importance and the order in which you have to use them. Which one must be solved first, which one can be solved last. All those are semantics. Now the most famous one, which we did in high school, is called the BODMAS. Now the BODMAS simply tells you how to solve an expression or an equation with these signs: brackets of division, multiplication, addition, and subtraction. So you must first solve the brackets before addition. If you have those two, you must solve division before subtraction. If you have those, you must add before subtraction, and all those. This is the order of importance. It goes from brackets to subtraction. Brackets is the most significant one, or the most important, or takes the highest precedence, and subtraction takes the lowest precedence. I hope that makes sense. Then you have the next one, which is called operator associativity. Now, once you understand what the precedence is, associativity becomes a little bit easy, because associativity means these are operators with the same importance or same precedence. So let us say you have an equation here that says 2 times 4 plus 3. Now, using the BODMAS rule, the BODMAS rule goes multiplication before addition, meaning that you have to multiply before you add, because if you add before you multiply, then this will give you a different answer. Now let us test those. Let's say we are starting with multiplication. If you start with multiplication, this will be 2 times 4, 8, plus 3, that will be 11. Now if you start with addition, that will be 2 times 7, which is equals to 9. Now this is wrong, this is right. So you must use the rules that govern these operators. Then I'm going to show you what it's meant now by precedence. Now with precedence, it means that these operators have equal importance. So meaning they have this relationship that is called left to right or right to left, meaning whichever way you solve them, it will always give you the right answer. Now let us take the same expression and put division here. So this will be, I will want to change that a little bit so that we don't have decimals. I'll say this is 2 times 8 divided by 2. Still, yes. Or maybe let's say 4, but 2 is fine as well. Now let us say we are starting with multiplication. Now this rule says if you solve from left to right or solve from right to left, it will give you the same thing, because they have the same precedence. Now this will be 2 times 8, which is 16, divided by 2. So this is not mod, this is division. So let me write this programming way so that it is not confusing. So this is division, this is division. Divide that by 2, you will get 8. And then if you start by dividing, you will get 2 times. So this will be 8 divided by 2 is 4. And then 2 times 4 is 8. Now this is what is meant by operator associativity, that they have the same precedence. So whichever one you start with, you will get the same answer. These one have different order of precedence. So depending on which one you start with, you will get a different answer. And then now we have that operator precedence that governs which one takes more precedence over the other, which is multiplication. So if you start with multiplication, you'll get the right answer. If you start with addition, you'll get the wrong answer. Then you also have addition and subtraction. Whichever one you start with, it will give you the same answer, meaning they have the same precedence. So multiplication and division, same precedence. Addition and subtraction, same precedence. Then moving on to type conversion using assignment. So what that is first, if you understand this term quickly, that is sometimes used, coercion. So this is the practice of persuading someone to do something by force. Now that does not sound well, but it's the definition of the word. So now, how the understanding of that word can be used is like persuading the compiler to change data type. So it is telling the compiler by force to change the data type. Now that's what type conversion is, but it's using the assignment operator. Now this is the other important part. So notice that I've skipped this point to come and just tell you first the importance of this assignment, right? Now let me just connect the dots and go back. The assignment operator now changes, just like the percentage sign, which we understood as division, but now it's mod. Division is this line in programming, which is the /. Assignment now does not mean equals to anymore. This is not equals to. So it's not that comparison. This equal sign means assignment. So it's an assignment operator. It just assigns values to variables. So you'll have a variable this side on your left, then you'll have that assignment, then you'll have your value on your right. So that is what an assignment operator does. It takes this value and assign it to this variable. Takes this value and assigns it to that variable. That's what the assignment is doing. So now that is used for typecasting. So you can define a value and then typecast it and then assign it as a different type to this variable. So I'm going to demonstrate that quickly using code. But let me just look at the last one. So typecasting is the same thing as type conversion. So it's assigning a value of a data type to a different data type. So the important word there is that assignment. Right, so if you understand what an assignment operator is, then typecasting and type conversion becomes easy. Now let us go to our IDE, and then I will show you quickly what type conversion is. Now we have two types of conversion. We have the implicit, which is done by your compiler. We have the implicit typecast, Then we have the explicit typecast. Starting with the implicit typecasting. So that casting is done by the compiler, which is why it's called implicit. It's implied. Now let us begin with a rather a simple one. So if you say int num, which is a number, is going to 4, 4.574, and then you see out that value, you would expect number to be 4.574. But what the compiler does is that if you look at these, on your right hand side you have a decimal, which is a double, and then on the right hand side you have an integer. So what the compiler will do is that it has to take that double and then cast it or convert it to an integer so that it can assign it to this variable, because this variable cannot contain any type but an integer, and an integer, it is a whole number. So what it does is that it will take only 4 and leave out all the floating numbers, which is after the comma. So let's test that. If you see out, okay, I just highlighted that, so it will complain for whatever reason. Then let me run that properly. And as you can see that it says that num is 4, meaning it has casted or converted a double into an integer. So that's what an implicit type is. So let me give you another example. Or now let me just maybe give you what an implicit looks like and what an explicit would look like. So for the same thing, if you wanted to cast it explicitly, you would have to write these brackets int. So this is what your compiler is doing on the background. It's just appending that int here so that it casts this double to an int. So now if we run this, you'll see that we'll have 2 4s here. Oh, sorry, num is initialized and declared twice, so we need to have a different variable for that. Pardon me for that. Clear the terminal, and then you will see now we have 4 and 4 there, 4. So this is an implicit typecast which is done by your compiler, and this is an explicit which is done by you. Now let us get another example of what an implicit typecast looks like. So we'll go into, let me take a character. Yes, let me take a character. So let me assign an int to maybe, let's say, capital letter A. Capital letter A. Now this is a char, which is a character assigned to an integer. Now what would you expect to be displayed there? It would be this A. However, if you look at that line, we are taking a char and assigning it to an int. So as I've mentioned before, that this can only hold an int. So we need to get the equivalence of what a char capital letter A is. Now quickly run the code. You will see that it sees out 65. Now you might wonder, where is this 65 coming from? Now you would need to understand or know about this thing called the ASCII table. Let me just try to pull it up quickly. You can check this online. If you just go to Google and type in ASCII table, this will come up. So these are the rules that govern the conversion between char hex and decimals. So as you can see, there is your capital letter A as a character. It corresponds to 65 as the decimal. So as you see that we took A as a char, assigned it to an integer. So that's the typecast that the compiler is doing. Now you can write that as an explicit by putting that int there. So that is what the compiler is doing. That is what is called an implicit. And then you may go further and then maybe say sum is equals to, maybe let's say now that's 65 plus 25. Let's add the 2. So now if you add those numbers and then you see out the sum instead of the A, so you know now that this, because this is an integer and then this is a character and then this is an integer. Now what your compiler will do is that it will convert or cast that char into an int, then it will add these two integers and assign them to an int. How also implicit typecast works is that the compiler checks the significant type and then it converts to the highest significant type. The highest significant type is a string, then a double, an int, going to float, which is the small one, short, and those. But your compiler will do that for you. But you can just go read up on how typecast precedence occurs. But here it will add that 25 with 65, and then if you run your compiler, you will get your sum there as 90. Then this is what implicit casting looks like, and it's done by your compiler. You don't have to worry about that. The compiler is doing it in the background. So you just need to know what it's doing. It's just appending int there, converting that A to 65 according to the ASCII table. Then it will write that for you. Now when we go to explicit typecasting now, I will do another calculation. So let us remove that C out so that we don't see two values. So here I will just try to do an arithmetic to make it a bit interesting, but it's the same thing as I've done in line 9 and 10. But what I will do now is I will throw in a double there. So you can have a salary, or you can have what can be a decimal. Let's say height. You have height, double, height, meters. So I'm going to assign that maybe to 15 or 210 point that. Then assignment there, sorry. Then you have you want to sum a double with an int and then assign that sum to an integer. Let us start with that one. Int sum. Let's say we want to add 50 more meters on that height. That's going to be 50 plus height. But since you already know that the height is a double, you will want to tell the compiler that no, this is not a double. So you are forcing the compiler here to say this is an integer, and then your compiler will take the equivalent int of height, which is just the whole number. It will add to that 53, then it will give you your sum. See out sum and line. Then when you run your code, you should then get an integer as your answer. What did I do now? It says redeclaration of sum. Okay, let me just remove that completely. Then there is 303. So that's how you force the compiler to change from one type to the other, right? Now, what I'm going to do is to also now make it a double. So I'm going to leave that as a double and then declare this as a double. So if you run this, it should give the answer as a double. So let's run that. As you can see, your answer is a double there because your compiler did a typecast here, because double takes the highest precedence compared to int. So it will append double there and then add the two doubles, and then it will give you a sum double. Now, to explicitly tell the compiler that this is a double, you can do it like that. Open brackets and then give it the type. Then it will be the same result. So that's what typecasting means. So what it does is that it takes what you have on your on your left. In this case, we do have a double. So it's a double to double. So there is no typecast besides this part here. This part we are typecasting here. So it takes an int 50 and make it a double 50. So you can make this an integer. So what it will do is that it will add that 50 as a double. It will add it to the height as a double, which the answer is supposed to be 303.65. And then it will change that type of double to an int and then assign it to the int. So it takes a double, change the type, and then assign it as an int. So you'll see that now you will only see 303. So now that assignment and that conversion typecasting was done by your compiler. So there is typecasting. I hope you understand that. So now what I'm going to do is to move on to the last part of this learning or session. So the last part now is I want to show you how to use the library functions. So these are important for building your equations. If you have any equations, I'm thinking of one right now, which is the Pythagorean theorem. Now with the Pythagoras theorem, you need obviously to have a right-angled. You need to have a right-angled triangle. Erase that. Ooh. And then you will have your height, you will have your base, then you will have your, let's just call that radius or whatever, or hypotenuse. And then once you have that, your Pythagoras. So this is they both look like a hypotenuse. No, let me just call the hypotenuse R. This is your hypotenuse. So how you will calculate the length of the hypotenuse given your base and height is that you'd say R is equals to the square root of height squared plus base squared. So now how you would write this with your functions, I'm going to show you right now. So let me create a new file here, which I'm going to call functions.cpp. So I'm just going to copy over some of the structure so that I'm quick. Then remove all that. Now I'm going to show you functions. Now a lot of these functions are in the math library. So you have to include the math.h library, which I have specified here in the notes. So now you have access to all the functions. Now the functions are already written for you. you don't have to write them, so it's a reusable code, which is really helpful, because if you were to write this code from scratch, that would be a real headache. Now, let me show you a couple of these functions. So off the bat, the one that I am going to use is the square root. So the square root, you just have to know how it is written, or the name, the class. Then the square root of 4, you can write there. So the answer here should give you 2. So if you run your code here, run code, so you will see that the square root there, it is 4. I'll be biased there. I will only put in perfect squares. So that's why I am assigning it to an int. And then let me just call this answer instead, so that it makes sense. Answer. And then you have answer here. Then this will obviously be the same number, because I haven't changed. So that will be 2. And then square root of 64, not 84. You get your 8 there. So there, you don't have to write the whole code for getting a square root. It's already written for you. There is a lot of these. So I can also show you one which is called the absolute, because I've written a couple here. Okay, absolute is also here. So absolute, let's say negative answer. So you take the answer and multiply it by -1. So as you know that now the negative answer will be -1. We'll be multiplying whatever answer by -1. So it was 8, and then my times -1, it's negative. So whenever you want to get or you want to make sure that you are getting a positive number, so this function may be useful for maybe having an asymptote at 0, meaning you only want positive values or negative values, but this one only gives you positive values. It takes all your values, both the double, which is decimal, and integers, and then it will give you a positive number. It takes a positive number, it gives you a positive number. It takes a negative number, it gives you a negative number. Now, if you want to make sure, whatever case, that all your answers are positive, you can just pass in your negative number, and then this function here will take in the number and return a positive number. So let us run that. It should now give us, I highlighted that, so we won't run again, then see it is positive. So it took that -8 absolute value, that's positive. So that's how you would use the functions. The power is normal power. So if you maybe wanted to say, okay, now take the 8 that is positive, let's remove this, take the 8 that is positive and raise it to a power of 2 and see what that answer is. It should go back to the square root, which is 64. So you are going to go answer, or maybe let's just say power is equals to, so it's power, it takes in 2 variables, 2 integers. The first one is your base, which in this case I just want to say it's 8, and then your exponent, which is 2, then this will take you back to your 64. So you can still put that into that positive number, does not matter, it's already positive anyways. So the answer here is going to be 64, because 8 exponent 2 is 64. And that, there's your 64. Change that to 2. 2 exponent 2, that is 4. There is your 4. So this is how you would use, so you would model your equations using these functions here. So what I will do now is to move on to showing you how to write an actual equation, which I have previously wrote here as Pythagorean theorem. Let's just give quick values here. Let's say this was 4 and then this was 5. So if you quickly put that into your calculator, this will be 4 all squared plus 5 all squared. Quickly calculate that. So that will be square root of 4 all squared plus 5 all squared, which is square root of 41 in decimal. I think our compiler will output at least 5. So this will be 4, 3, 1, 2. Let me just pen the 6th one. So we are expecting to get something similar to this, but it will be in 5 decimal places, I reckon. So let us go and write the Pythagorean theorem. Now int, I will say that's the answer is going to be double, of course. Then you have your hypotenuse is equals to the square root. Now the square root, as you can see, that it is power, height, and power are base. Now what you want to do is to go power, right? And then base, B for base, exponent 2. The base is raised to power 2. The height is also raised to power 2. Then add to power and then height power 2 as well. Now you obviously have to declare your power, your height as int height is equals to 4 and int base is equals to 5. Save that, and then we need to terminate that and then see out our hypotenuse and line. Let's see if that will give us the corresponding answer. Clear the terminal. Then the answer we're expecting is 6.4. Now let me run that. There, as I've said, it took 5 decimal places. So that's 6,40312. So that's how you can use these functions to model whatever you want. It's the same function in your calculators. So you can have them now in your program to model any equation that you want to model. Now let's move on to the last one, which I want to focus on a little bit. Now let us not use or remove this calculation here. It's perfect for this. Now let us say you wanted to model your answer. Maybe the question or the requirement was to leave this answer in 2 decimal places. So these are 2 decimal places. We have to round off that one, which is less than 5. So your final answer would be 6.4. Now to manipulate your numeric output, so the first thing that you need to do is to include the IOmanip header file, as I have showed in my notes. IOmanip. Then to round off your answer, which is currently in 5 decimal numbers after the comma. So we've shown here that what we want is 2 decimal numbers after the comma. So to set your precision, you need to see out set precision before the actual numeric value that you wanna manipulate. So for you to round off to 2 decimal places, you need to count like this. It's the number of decimal places you want plus 1. Meaning that if you wanted to round off to 2 decimal places, that's 2 plus 1, so you put in 3 here. Then if you run your code now, it should see out 6.40. As you can see that what we have here is 6.4 because this 0, even if it's there or not, is the same thing. So to make it a little bit clearer, let us round off to 3 decimal places so that it can write that, it can add that 0 because there is a 3 after 0, because if it's 0, there's no need to write the 0. Now what I'm saying now is that the requirement is that we need to round off to 3 decimal places after the comma, meaning it's 3 plus 1, which on your set precision you need to say 4 to get that number. So we'll go back and append your 4 here, save and run that. Then there is your number 6.403. Now that's how you would manipulate your numeric value in terms of digits after the comma. Now the ones that I've written here, as you can see, there is this thing called fixed. So this one, how it works is that if you had, let's say you had a scientific value, you were calculating for some reason, hypo was giving you a scientific value maybe of 1.23 exponent 9. So that's how we write a scientific notation in C++. So if you see out now, you will see that hypo now is in scientific notation. So if you do not want that in scientific notation form, what you need to do is to see out fixed first before the actual value, so that it sets the flags off which govern the see out from displaying a scientific value. So this just turns off the compiler, or sets the compiler to not output your scientific form. So it converts that into a numeric value, a number or a whole number instead of being represented in scientific format. So I've highlighted that, sorry, rerun this. So as you can see there, so that's 9 positions. So from here, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there, 1.3 times 10 exponent 9. So fixed is just turning off the scientific form flag. Then the last one is set with. Now this one is very, very interesting because I did not understand it before. I just learned it recently, that so there is a way of setting a fixed width for your values. So this also works the same way. You have to put it before the actual value. So now if we had looked at, let's just remove this and say hype now instead is the addition of the two, height and base. So that will be 9, of course, right? Now what the set width does is that it sets the width of the output before the output, meaning if I say 5, so the width of the output space or the value is 5 spaces or 5 characters. Now if your hype only has 1 character or 1 value, this width will have 4 spaces that are unoccupied. So what it will do is that it has set out 5 spaces, right? They are not zeros, but it's just spaces. So if you have 9, it will only append 9 at the end, and then this space is left empty. So you'll see that now before 9 there'll be a space here, and then if you run that, I highlighted that, sorry, run. So you can see that 9 now is outputted at the far end because there is 4 spaces between 9. So let us set the width to be 1, meaning that we only have space for 1 character. If you see out that, you will see that there is no space now. Now let me remove that so that we can play with this nicely. So let us say now it's 23 instead of 9. Now let us say we have two characters or two numbers. The set width, what it specifically does is that it sets the minimum, it sets the limit for numbers. It sets the minimum space. So if you have 1, it will be occupied. If you have 2, it will then add both of them. If you have 10, it will add all of them. But if you had 10 here, it has 10 spaces. So those two characters will only occupy those 10 spaces, and there'll be 8 spaces left before it appends that 22. So now there's this padding of spaces. But if you say 1, so you have only one space, that one space will be occupied and then it will be extended. So it only sets the limit. So now you can see that the space that we have set with that set width is occupied by 2, and then all the other values can be displayed as well. So what set width does is that it sets the minimum width, meaning that if your characters, they are less than the space, it will just append that space. If they are more than, they will occupy the space set, and then the compiler will add more space. So that's how the set width works, and that's how you would manipulate your numeric values. I hope you enjoyed the video. Thank you.